When you begin this module, you will be given a bag of components that you will be using. This will include the ARM board, the sensor kit, the 16-button keypad, a servo, a breadboard, a connection for the ARM board, and wires for connecting components. The sensor kit contains multiple different sensors that you can utilise alongside the ARM board. The sensors are listed on this card here. The ARM board has many different components that you can use. The front of the board has an LCD touchscreen display. The back of the board has an Ethernet port, GPIO connectors, push buttons, 2 micro USB connections, an ST-Link connector, audio jacks, and more. The technical manual contains more information on these components. The GPIOs on the back of the board are used heavily in the Embedded Systems module. Each pin is labelled, with some pins designated as ground connections or power outputs. More information on what each pin does and how to access it in your code is also detailed in the manual. On page 23, you will find a mapping between the pins on the ARM board and the GPIO pins. On the ARM board, you can find D0, D1, D2, etc., which are mapped to their corresponding GPIO ports. For example, as shown in the manual, D0 maps to PC7 and D15 maps to PB8 respectively. To utilise the boards, we need to write a program for it. We can do this using the Keil IDE. Once we've opened the program, we first need to install the relevant packages. We will open the Pack Installer, select the Boards tab and search for the model of board we are using. Now we can click on the Packs tab, find the key or pack for this board and install it. When the download is complete, the icon will display Up to Date. To start a new project, click Project, then New UVision Project. In the window that appears, navigate to the folder you wish to store your projects in. You should create a new folder for each new project. In the next window, you want to find the board we are using. This will be under STM Microelectronics. Navigate through the menus until you find the board. Now we want to select the components we will be using. Select the packages you will need for this project. These should be listed in the lab sheet. Click OK to finish. Click on the Save All icon to save this configuration. If at any point you need to add or change the components you used, you can click this button to access the Runtime Environment window. To add some code to our project, we can right-click on Source Group 1 and add New Item to Group. We will be using the C programming language for this project. Name your file and click Add. Don't forget to save and update your changes. This file is now visible in the source window. To add header files to our code, we can right-click on the file, select Insert #include file, and choose the header files we need for this project. Now we can add some code. We'll click this button here to build the program. If there are no errors or warnings, the program is written correctly. Finally, we want to flash our program onto the ARM board. Click this button to open the target options and select the Target tab. Here, select Use Microlib to optimize for smaller code. In the Debug tab, choose the ST-Link debugger option. Then click Settings, and in the Flash Download tab, select the Reset and Run option. This will allow your program to begin running as soon as it has been loaded onto the board. Now click the Debug tab and change the port to SW. On the Utilities tab, click Settings and make sure the program algorithm matches the one shown here. Save all and build the program again. To load our program onto the board, we click this button here. Here is the Blinky program working on the arm board.